Today I want to go ahead and talk with you about some of the basics of probability from Chapter 4. And one of the first things that you have in Chapter 4 are the different types of probability. First type that you have is your classical. Now, classical type of probability is nothing more than results from experiments that you already know, like rolling a die or pulling cards or something like that. Like the casino night that you might have gone to that's student government sponsored. Another type is subjective. And with subjective probability, it's nothing more than how somebody feels about something. It's a real soft measure of probability. And the third one, and the one that we'll probably use the most, is called the relative frequency of occurrence. And what that is actual data. So you could have data on, rolling a die, and then you could have the classical probability of it and see whether or not they match. Now, in all things with probability, the general formula is the following. The probability of an event, and we'll call that event E, is nothing more than the number of favorable occurrences over the total possible. And that works no matter what type of probability. Now, there are some rules of probability. First of all, the probability of an event has got to be between 0 and 1. You can't have negative probabilities, and you can't have something that's more than 1. The other thing is, if you have events, multiple events in a sample space, when you add up all of those probabilities, it equals 1. Now, there's one other thing that you might see in probability. It's a thing called a factorial. And a factorial is denoted by n with an exclamation mark. Now, that is not an excited n. What it means is shorthand. Let's say I wanted 5 factorial. Well, 5 factorial means 5 times 4 times 3 times 2 times 1. Now, if I multiply that out, 5 times 4 is 20, times 3 is 60, times 2 is 120. So 5 factorial would be equal to the number 120. Now, we use this whenever we're dealing with the counting principle. We use it when we're dealing with combinations of n things taken r at a time. We use it with permutations of n things taken r at a time. And we're going to talk about that a little bit more in class. Now, one of the problems that you had in section 4.2 was an inventory problem. It's example 4.8 in the book on page 141. And in this example, what we have are boards that have dimensions of 2 by 4, 2 by 6, 2 by 8, and then you have lengths of 8, 10, and 12 feet. Now, anytime that you're working on something like this, we're dealing with relative frequency of occurrence because we have actual data. Now, in the book, it just gives you the general matrix of the dimensions and the lengths. And I've gone ahead and I have totaled up our columns and I've totaled up our rows. Now, one thing that you need to understand is each one of these columns is considered to be mutually exclusive, meaning if it's a 2 by 4, it can't be a 2 by 6 and it can't be a 2 by 8. Okay? Now, I'm interested in choosing a 2 by 4 that's either 10 feet or longer. Well, what that means is I want the probability of a 2 by 4 that's 10 feet, or I want a 2 by 4 that's 12 feet. Now, this or means add. And if I look at probability in this particular case, a 2 by 4 that's 10 feet, well, how many of them are there? If you read down the column and you read across the row, there's 2,000 out of the 18,000. That's my probability of 10-foot 2x4s. The probability of 12-foot 2x4s is going to be, well, 1,600 out of 18,000. And if I add this together, I get 3,600 out of 18,000, which would become 0.2 if I were to go ahead and put that in decimal form. Now, I can say it's 0.2, I can say it's 20%, I can't say that it's 20. Because remember, we already said that probability had to be between 0 and 1. Okay, let's look at something else in this particular example. Suppose I was interested in finding a 10-foot board, and I knew, so I use a little line here and I say given, that I have a 2x4. Now this is called conditional probability. And when I'm dealing with conditional probability, there's a formula in the book. But if I have relative frequency of occurrence, I can go over to the data and I can cut down my sample size. And in this particular case, notice, if I know that it's a 2x4, I don't have to worry about the entire 18,000. All I'm interested in is the 5,000 2x4s. So my total amount here would be the 5,000. Now, how many 10 feet 2x4s are there? Well, there's 2,000. So my conditional probability here tells me that it's 2 out of 5, which would be a 0.4 or 40%. Okay? Now with conditional probability, again, the formula is out there in the book, and we know that we can go ahead and we can cut down sample spaces. There's a lot of other topics that we have to go over in Chapter 4, but I want you to go ahead and look through these. There's a worksheet out on Blackboard, and I want you to print that off, go through that worksheet along with the other one that I had dealing with the PowerPoint, and I'll see you in class on Thursday.